Okay, continuing on for the second part of the question. I kept the data from the first time in that there is information on what we determined in theory should have been formed with my made-up data, and then what actually was formed. And this was looking at copper chloride, the solid. So you remember in our lab, we took that and then we added it to some water and then did the second part of the reaction where we put in aluminum and saw the results. So this is an example of one of the results that you saw, where the aluminum was kind of eaten up and we were left with this brown solid on the outside, and the liquid itself turned clear. So in this reaction, if this was the second part of that question and calculation, it asks for you to say, okay, given how much of that you actually formed, so you want to use your data from the actual lab, not in the theory, how much aluminum would you have needed? Well, really what we're asking is, getting to our example of a recipe, is that given the amount of copper chloride that was in here, and I put my piece of aluminum in, is I want to know how much of my aluminum should be eaten up and used up, because this is a chemical reaction. It needs two parts to run. It needs aluminum and my copper chloride. So I want to ask myself how many grams of this would I have expected to react given that I used 3.25 grams of copper chloride to start. Okay, so I'm going to start with that number over here and say, okay, 3.25 grams of copper chloride. Okay, that's how much created that blue solution in this case, my hypothetical case. So I created that much, I dissolved it in water, and it doesn't really matter how much water I put in, because as long as it's all present there to react, that's where I'm getting this 3.25 grams. So the first thing I want to do is to go into, well, how many moles is that? So it's the same kind of idea. I want to find the molar mass, or use the molar mass of copper chloride. So for every 134.4 grams of CuCl2, that's the same thing as 1 mole CuCl2. The reason I do it that way is so that now I can cancel out the units of grams and be left in moles. Okay, I'm not quite to my answer yet, but at least it lets me use my equation. So now what I'm saying, when I'm here, is I want to look and say, okay, I've got that many moles of copper chloride, whatever that might be, and now I want to make a connection between copper chloride and aluminum. This is like saying, if you're going to use up 6 eggs in your pancake recipe, how many cups of flour do you need to react with or to mix with those 6 eggs? You want to use your recipe as a way to connect any parts of your reaction. And in this case, I want to know, for every certain number of moles of copper chloride, how many aluminum should I need as well? All right? So I look to my equation. This part here, you always want to look to your equation and say, what does my recipe or my equation tell me? It tells me that for every 3 moles of copper chloride, I need 2 moles of aluminum. Again, that's just reading right off of here. So 3 moles of copper chloride are needed for every 2 moles of aluminum. Or 3 parts copper chloride for every 2 parts aluminum. Alright, so I do that now, and that cancels, and I'm left with, I'm now in moles of aluminum. I'm almost there, because I want to turn this into grams. And so I'm going to multiply this by, for every mole of aluminum, how do you find out the molar mass? You look to any substance, you look on the periodic table, in this case aluminum. It's off the screen there, but it's 27 grams per mole. 27 grams of aluminum and 1 mole of aluminum. And so these cancel, and you're left with, when you do all the math, how many grams of aluminum should have reacted with my copper chloride. So as we run this through, and as you check it out, you should get a number that is related to and tells you how much you'd expect from that. And so just quickly, we can do that together. Here, 3.25 grams of my copper chloride, 3.25, and I want to divide it by 134.4. Now, at this point, I want to multiply by 2/3, however you want to do that. Some were asking, you could multiply by 2 and then divide it by 3, however you want to do it, but figure that out here. And then final step, you want to multiply that by 27. And you get about 0.44 grams of aluminum. That is how much we would have expected to use up in this case. Okay, again, going back to our actual chemical reaction, what happened, if you look at this piece here, any one of your pieces that you looked afterwards, it ate away a lot of the aluminum, and we would say that in this example, given my starting materials, I would expect that it's going to eat away about 0.44 grams of aluminum. Okay? We didn't measure this for a couple reasons. One, we saw there's a lot of plastic that kind of got in the way of our measurements. It also kind of interfered with how we could filter this, but that's the idea. If I asked it, I could also ask to figure out, given how much of this that goes in, how much copper would I expect to get out? I do the same kind of logic, only I would change the ratios and change the molar mass. So the two examples I gave are the ones I asked for the lab. Make sure you ask questions and be ready to go when your lab is due, and let me know if you have anything else here before class on Monday.